Welcome back, everyone, to another episode. Thank you all for joining us. Chris, how are you today?
I'm doing very well, thanks, Jake.
Good to hear. Good to hear. So we have I guess you could say this might be our first episode where it's sort of like audience suggested topic. So a lot of you guys have asked about this particular topic, and that is why we are covering it today. I'm not going to give away what it is, but it's probably going to become quite obvious when I talk about the Silver Era workout plan in a moment. But I do want to say thank you guys for your suggestions. I've had a few people give me suggestions over the last week, and we do appreciate it. We, of course, appreciate you guys sharing and commenting and doing all the good stuff, subscribing. So please continue to do all of that stuff. So today I'm going to introduce us to not a full workout, but just a bit of, it's sort of like a specialization, I suppose. And last week we did talk about a specialization phase. And this is, I suppose, another form of a specialization phase. And this is actually coming from John Grimek. Now, I think I would have mentioned John Grimek in the past on other episodes, but I don't think we've talked about one of his plans yet. And we will at some point go into plans in more detail. This is just a specialization part. But Grimek was very, very important when we look at the Silver Era. So he was the first Mr. Universe back in 1948. And in fact, there's several very interesting things about John Grimek. So first Mr. Universe, he won multiple Miss Americas. He competed in the American Olympic weightlifting team in 1936. And the story of how he did that is very interesting. I actually find this, people look at bodybuilding today, and there seems to be this kind of dichotomy where like, well, bodybuilders aren't that strong. And if you look at the Silver Era guys, they were the strongest guys on the planet. And, the story of Grimek competing in the Olympics, like he wasn't even preparing for that. He was doing his bodybuilding, weightlifting stuff, just being a strength athlete. And then essentially in the lead up to the Olympics gets contacted by Hoffman being like, hey, basically we need you to join our team. And he was strong enough just in his normal day-to-day training that he was able to step into that role. We see people obviously, like we've talked about Reg Park in the past, second person to bench 500 pounds, and obviously a bodybuilder by trade. So the Silver Era guys were incredibly strong. The idea that strength and muscle were separate, like that just didn't compute. Anyway, I'm going off on a tangent. So 1936, Olympic competitor. And the other interesting thing with Grimek, so he was part of the York Club. So we've talked about Hoffman quite a bit so far. So he was one of Hoffman's guys. And he was potentially one of the first, at least based on the documentation we have, one of the first American bodybuilders to actually experiment with steroids. Now, this was documented in 1954 as part of a group of lifters at York Barbell. And it's worth noting, because people might be like, well, why are we talking about Grimek then? But Grimek was 44. I think he would have been 44 thereabouts when he experimented with steroids with York. So he'd given up competing half a decade earlier. All of his competitions that he'd won were done well and truly before he experimented with steroids. And by all accounts, in fact, the first experiments actually didn't even work. They got a stack of side effects and no benefit, and apparently aborted the experimentation. And then a year or two later, that's where D-bol hit the market, and that was obviously more successful. But nonetheless, John Grimek does come up quite a lot if we look at the history of the Silver Era. Now, this plan or this specialization phase that I'm talking about, I will admit that this was published post steroids. But as I've said, Grimek had finished competing well and truly by that point. And he talks about this as a method that he used to build his arms. And he does say that when he was writing this, he says that people now are talking about high volumes and they're talking about doing thousands of curls. And that's what he's talking against. He says, no, that's not how we did it. It was stuff that got you strong. And he talks about using this at the end of a workout. So as I sort of discussed last week with specialization phases, often they would take out, say, the exercises for that particular muscle from a normal full body workout and then add this either at the start or at the end, or sometimes even on separate days. So that's what Grimek was suggesting with this for specializing in arms. And what he suggested doing was getting a barbell and setting up a power rack and setting up the barbell in the power rack. So it's up against pins, so it's immovable. And at a 30 degree of elbow flexion, 90 degree and 150 degrees, doing a max effort, 5-second isometric in each position. Just a single 5-second isometric. And resting between each set so you could give max effort to each set. And then he suggests doing the same thing for an overhead press and setting it up at eye level, at hairline level, 6 inches above the head, and then 2 inches before lockout. And once again, doing 5-second max effort, isometric as hard as you can, resting between each set and doing the other positions. So that's the first we've talked about isometrics, at least on this podcast and any of these plans. Chris, what do you have to say about those?
Well, I think it's absolutely fascinating. We've got some really, really good stuff here. I think it's very close to a perfect example of an isometric training program for hypertrophy. And I think there's a couple of things I want to kind of draw out here, at least 3 if not 4. So first things first is using maximal effort contractions. I think that's important to reiterate, and not using submaximal ones, so making sure we get a very high level of motor unit recruitment there. Secondly is not overdoing the duration of the contractions. We've got 5-second contractions. Really, really interesting, because actually that is the standard duration for a maximal isometric contraction in research studies. So that goes to show just how nailed down that is as a practice. And also we've got these different joint angles, so we're getting different regions of the muscles or different muscles within a group being stimulated. And then finally, the volume is actually quite low. So, and I know you've already made that point, but I think it deserves to be reiterated that they're not talking about doing a ton of kind of low quality contractions here. This is designed to be high quality work that is increasing recruitment, increasing kind of the hypertrophy in very specific areas of the muscle. I think it's a really, really good example of just how dialed in those guys were.
Yeah. And we're going to talk more about ways that one can implement some of these things. And obviously this is an example of that. And we'll talk about how we've done that in our own programming a little bit later on. But to begin with, let's unpack what exactly is happening. Like why would someone do isometrics like this? Why would someone, you've mentioned 5 seconds. Why 5 seconds? Like, let's actually unpack this topic.
Well, let me start by answering because obviously, as you said at the beginning of this podcast, we're doing this topic because people have asked us to. And in doing so, in asking us to cover this topic, they have actually sent us a whole list of specific questions relating to all of these issues. And I've just kind of got an order that I think works to run through these. So let me just insert one topic before I answer that question, which is, can isometrics actually cause hypertrophy? And if so, how are they doing that? Because that's like the preamble, that's like the background to all of this stuff that we're going to be covering. So the stimulating reps model is not about numbers of repetitions, as I've said before. It's about physiological reality. How is muscle growth being stimulated? And the stimulating reps model tells us that we stimulate muscle growth on a whole muscle level by point A, or starting at the beginning, achieving a high level of muscle fiber activation, by which I mean a lot of muscle fibers are activated. Now we do that by recruiting a high level of motor units, so a lot of motor units, and that allows us to activate a lot of muscle fibers. So that's step 1. Step 2 is then we have to apply a high level of mechanical tension to each of those muscle fibers. Even today, I'm seeing people saying things like, oh, well, if I devote a high level of effort to this contraction, I'm going to feel a really high level of tension in the muscle, and that's telling me that I'm experiencing hypertrophy. That's just not how hypertrophy works. Hypertrophy is a muscle fiber phenomenon. You're not going to be able to feel what's happening at all. What's actually important is that each individual fiber experiences a high level of tension. Now, how does it do that? It needs to be moving slowly. Well, in a slow concentric, obviously we're moving slowly, but some people look at an isometric and go, well, we're not moving, so I'm not moving slowly, so I'm not getting this. Yes, you are. So the static state, the zero velocity, is basically just as good, if not slightly better, than a very slow movement velocity. So the actin myosin cross bridges are creating a high level of single fiber tension at zero velocity in the same way that they do at a very slow concentric velocity. So essentially, the isometric is giving you automatically that very slow shortening velocity, and that then paired with a high level of effort, which is why I mentioned Grimek's, kind of focus on maximal efforts being important, that is then critical for the other side of the equation. So basically, in a maximal effort isometric, we are essentially getting the same thing as we would get in the last couple of repetitions of a heavy, or any strength training set really, but let's focus on heavy loads because that's what we talk about. You get a heavy load or a moderately heavy load, you're basically getting the same kind of experience from your isometric as you are from those last stimulating reps of a set if your efforts are maximal. So essentially that's how isometrics cause hypertrophy in exactly the same way as a heavy strength training set would do.
That's a really interesting and important point where you've talked about, because people will look at this and be like, well, based on force velocity, if there's no movement, then that's not doing what it needs to do. And as you've just said there, no, what we're talking about is the cross bridging between the actin and myosin. And you're saying that even at that point of no actual movement, there's maximal cross bridging that's occurring. So that is a misconception I see a lot online, where people are thinking, well, if there's no velocity at all and nothing's moving, then there's no tension. No, that's not how that works.
Exactly. And ultimately, what's important is to start with the physiological reality and then interpret that from an understanding of how physiology works. I think what happens is people come at this space from different, trajectories, different directions, different backgrounds, and they don't understand what actin and myosin are doing, and they just hear force velocity and they just interpret it in a way that isn't actually correct. If we start from physiological reality, we can see that an isometric contraction is doing exactly the same thing as a slow concentric, so you can literally just treat them from a physiological point of view the same. Now, we'll get into some differences in a minute because that was your question, but ultimately the starting point is that yes, isometrics will cause hypertrophy, and they'll do it in exactly the same way as a dynamic set done relatively close to failure. So the question you had for me was essentially, what's I think it was what's different. Was that correct, or was it a slightly different direction that you were taking at that point?
Yeah, I was just, what are the parameters? You've talked about 5 seconds and max effort. So what's actually, and you've explained a little bit what's happening. We're still getting this cross bridging, but there's more to it a bit as well.
There is. So ultimately, putting this in context, we can say that if the isometric is behaving much like a dynamic, then ultimately you can start with what we know about, which is obviously heavy strength training or moderately heavy strength training done to failure, and we can go, okay, well, if a moderately heavy strength training set done to failure, or a heavy strength training set better still at 5 repetitions, if a 5 repetition maximum takes about sort of 12 to 15 seconds to be completed, I'm just thinking about the concentric phases because the eccentrics aren't really doing very much. But if you just time the concentric phases of a 5 rep max, you'll around about get to somewhere between 12 to 15 seconds. So you could say, well, okay, the whole of that set is stimulating hypertrophy. It's an entirely separate conversation about whether every single rep is equally stimulating or whether we can even judge the stimulus based on the time or anything like that. But let's assume we can for this conversation. Then you're probably going to find that approximately 10 to 15 seconds worth of isometric contractions get you to about 1 set's worth of hypertrophy stimulus, more or less. You could argue that the isometric would be slightly better if it's done with the way that Grimek's done it. It might be slightly worse if you do it in a way that's not quite so good. I'll get onto that in a moment. So ultimately, if we now translate that back to Grimek,
10 to 15 seconds worth of high levels of mechanical tension is what we're looking for there.
Exactly. Now, if we translate that back to Grimek and say, well, okay, so he's doing these, I think it's 3 separate contractions at 3 different joint angles.
For the biceps it was, and I think for the overhead press it was 4.
As 4. So essentially he's getting about somewhere between a set and maybe a set and a half, depending on how you slice it. So it's definitely a full set, at least a full set, and maybe a little bit more depending on, as I say, how you judge it. But definitively it's clearly a good set there. So he's getting 1 set and a bit from each of those efforts that you're doing, which is a really solid kind of addition to something that, because you said you're doing this in addition to what you're already doing. You're only adding 1 extra set, really. It's just a very judiciously segmented set where he's training different parts of the muscle. Now, the important thing about the 5 seconds is that if you look at the way that fatigue mechanisms build during isometric contractions compared to dynamic contractions, the dynamics, you get these little reset points between repetitions. Now, in isometric, you don't necessarily get that unless you do what Grimek has done, which is put them in. So by putting these 5-second contractions in and saying, well, I'm not going to go longer than 5 seconds, you're creating the equivalent of a essentially final rep of a set, somewhere between 3.5 and 5 seconds long. Now, if you don't do that, if you just go, I'm just going to do 10, 15 second contraction, what you're going to find is that the spinal central nervous system fatigue starts to build quite rapidly and starts to chew away your ability to create recruitment at the muscular level. Even though you're experiencing a high level of effort at the end of the set, you go, oh no, I'm pushing as hard as I possibly can. The recruitment levels have actually dropped quite a lot. And ultimately that is then disadvantageous. You're starting to pull away from what you were hoping to get, and you're not going to get the same stimulating effect. So that's why these 5-second contractions are just so much more valuable than allowing, kind of 10, 15, 20-second contractions to come into play.
I'm sure you're going to tell us about what it is fatigue-wise that's causing that, but just from a practical standpoint, I don't know if people listening to this have ever given isometrics a go, but if you haven't, go into a gym, set up a bar in an immovable position, do a curl against it, and you'll find that for 5, 7, maybe 8 seconds, like you can feel that you are actually really, and I don't mean max effort, but you're able to really, like you can feel how much force you can create doing that. And then you keep going, do 10 seconds, do 15 seconds, and you feel like you're doing max effort, but you can intuitively tell there's just nowhere near as much force that you're able to produce at that point.
Yeah, proprioceptively, you can tell that the external impact of your effort is no longer what it was.
Yeah.
And I think that's a really important point. I mean, I think it takes a little bit of thinking about to get to that level of perception, but it's definitely happening. So ultimately, the fascinating thing about spinal central nervous system fatigue is that it's been one of the most and I say well researched in a qualitative sense, not a quantitative sense. You're not going to find 100 studies on spinal CNS fatigue, but you are going to find probably 10 absolutely brilliant ones. And the sad thing is that the way that research works is that you are trying to falsify hypotheses. And unfortunately, these guys have done such an amazing job that they've falsified every single hypothesis that they've tested. And so they've done some absolutely remarkable work in a objective sense, in the sense that the quality of their work is just unbelievable. When I read the papers, I'm like, these guys absolutely know what they're doing. And yet they falsified every hypothesis that we've had so far in this area. So at the moment, all we really know about this process is that the longer the activation of the motor neurons or the recruitment of the motor neurons goes on for, the more the motor neurons start to resist the transition of that electrical signal to the muscular level. So essentially, it's like you start sending electricity down the spinal cord motor neurons to the muscle to recruit the motor units and activate the muscle fibers. And little by little, as time goes on and you're still doing that, the ability of the motor neurons to transmit that information starts to get throttled, and it gets smaller and smaller and smaller, and you get a smaller output for the input that you're putting in. Why is that happening is an absolute mystery, but as I say, not for want of trying. There's been some really great work done on this. It's just, unfortunately, it hasn't borne fruit. And interestingly, actually, from just a philosophical point of view, you might take a step back and go, maybe that would happen more in other areas if the research was actually as good. Maybe we'd find more negative results if people were putting the same amount of dedication and care into their, and care I think is the right word here, because you can kind of see that at every step of the way as they're going through their papers, as they're documenting what they've done and they're explaining to you how they've done this experiment, you can see that they've actually put a lot of thought and care into each step of the process. So many research papers you look at and you can just think that people have just thrown something into a kind of a rough shape and gone, oh, that'll be good enough, let's run with it. Whereas these guys, the quality of their work is extraordinary, and yet they've not managed to find a result that is helping us expand our understanding. Well, you could argue that they found some things that are not true, and you could say that's helping us expand, but it's not helping me build a model because it doesn't give me anything positive to work with.
Yeah, that's really interesting. Hey, like it even just, as you said, philosophically, it gives a different spin to what we see when we look at research papers, doesn't it? And I know from my perspective, there's a lot of papers I look at and I'm like, why are you doing it like that? Like that, just the method that you've chosen fundamentally means the outcome doesn't really matter because it's not even assessing what this issue is you're seeking to assess. So to see people, as you said, they're taking care and actually constructing how this goes, that's really encouraging, isn't it?
It's tremendous. But a lot of the stuff that's pure physiology does tend to attract that type of approach. The further away you get from pure physiology and the closer you get into things like, hypertrophy research, the worse things tend to get. I think there's like pockets of quality here and there, but Hypertrophy research is not renowned for those pockets of quality.
So what do we know about the fatigue mechanisms then?
So what we know is that the spinal CNS fatigue is going to be more rapid if you allow your isometric contraction to go on for longer. And that's the important thing. So what we can do is we can split up the isometric exactly the same way that Grimek has done and go, we're just going to do 5-second contractions. We're not going to try and get our entire stimulating rep dosage in one go. We're not going to do a 10-15 second contraction. We're going to do 2 or 3 sort of 5-second contractions, or however you want to do it, and that's going to be the best way of doing it. So in practice, actually very simple solution to avoiding the problem. We don't need to worry too much about that. Just remember, you don't really want to be doing 10, 15, 20-second contractions in an isometric state, because by the time you get to the end of that, the recruitment levels at the muscular level have dropped quite a long way, and that's before we even talk about what's happening at the supraspinal level, where you might be starting to lose motivation or getting a negative sensation.
Do we know how long one needs to wait for that to dissipate?
So this is a really interesting question, because the dissipation of CNS fatigues is quite controversial for a number of reasons, and it's also plagued by a little bit of methodological difficulty. Now, in recent years, that's been unpicked to a certain extent. So what we've got now is an understanding that there is a very quick recovery of a large chunk of both spinal and supraspinal CNS fatigue as soon as you finish the contraction. But it then goes non-linear and you get this kind of long tail happening. So unfortunately, once you've done something that is a maximal effort, for a few seconds, you probably are going to see a chunk of both supraspinal and spinal CNS fatigue lasting for, probably a couple of minutes. But as I mentioned a moment ago, big chunk of that does pretty much go within the first kind of minute or so. Now, I've just been looking at this a little bit more recently. I've been trying to pull together some studies that I've not spent so much time looking at and trying to gather a picture. And I think really, standard rest periods are pretty good at getting rid of most of this problem. I think 3 to 5 minutes is pretty much, a good rule of thumb for these kind of things. I just saw a study which showed that there was still some CNS fatigue even after 3 minutes, but I think most of it is recovering at that point, and it is mostly gone. With 5 seconds, I think we're really minimizing that. I mean, most of these studies that measure supraspinal and spinal CNS fatigues tend to use much longer duration contractions, even, like a minute long or something like that. So I think realistically, with 5-second contractions, we can probably take a minute and be absolutely fine. I don't see there being a problem after about a minute for those kind of situations. And to be honest, if you're setting this up like Grimek is describing, and you're setting up different height situations, you're probably going to need a good 30-45 seconds anyway, just to reset yourself.
Yeah, that's what when I do use these methods in my own training, that's what I do is I don't, often if I was doing just dynamic sets, I would be waiting longer. I would wait that sort of 3 or 4 minutes, whereas here I'll set up a new position. That'll usually take me probably 45, 60 seconds. And often, if you're setting up positions, you have to unload and then load again. So it is a little bit time consuming, and then I would go again. So that's probably going to be, maybe 60, 75 seconds, give or take. And because generally speaking, there's not going to be much cardiovascular demand with these types of sets, or, isometric sets anyway. Maybe if you're doing a squat, perhaps, but generally if we're doing overhead pressing, bicep curl, stuff like that, it's not going to be overly demanding, is it?
No, I think it really is going to be mostly spinal CNS fatigue. And as I say, that really does come zooming back down after the end of the set or the end of the repetition or the contraction. And you're just kind of dealing with a long tail after that. And I think a minute probably is a good compromise. Nobody wants to be, waiting 3 to 5 minutes between 5-second isometric contractions. I think 1 minute is definitely the right ballpark there. I wouldn't go less than that. I'm kind of stuck in an environment at the moment where I'm playing around with isometrics because I don't have access to a very good gym. And I'm finding that the minute really does make a difference. If I do an isometric and I like to just have a walk around and get my head straight again before I do another one, I think it does help. But, obviously that's practical, more anecdotal approach rather than the physiological one.
So what else do we need to be aware of fatigue-wise? Anything else?
So the other thing to be aware of is that, and actually I didn't mention this when I was looking at the routine, and it's just occurred to me to go back and check what order he did his contractions in. So I'm assuming that 30 degrees is a contractor position and that 150 degrees is the extended elbow position.
I'm not sure. I haven't seen any photos, so I'm not sure. The overhead
But the overhead
pressing,
press
he
is the other way
obviously goes,
around.
yeah.
But it's actually not that stretched. He's starting at shoulder, which is, I mean, I guess that is quite stretched, to be honest, if he's...
Yeah, fairly.
So the important thing is that when we look at different joint angles, we are going to experience fatigue mechanisms that are specific to muscle length. Now, the more contracted position you go, the more metabolites you're going to get, and they are totally and utterly innocuous, really. The more stretched you go, the more calcium ion fatigue you're going to get, and that is problematic. So realistically, I would always start at the contracted position and work my way down to the stretch position in that order, because you're going to have a conflict between your stretch position and your contractor, but you're not going to have a contractor position impact on your stretched. Now, let me just jump in and predict a point of contention that we might see in the fitness industry as a result of me saying this. Yes, you can find studies showing that contractor position isometrics cause more absolute fatigue than stretch position isometrics. You can find those studies, they do exist. That's not what I'm talking about. The magnitude of the fatigue is totally and utterly irrelevant. It's the fatigue mechanism that matters, because metabolite-related fatigue doesn't reduce mechanical tension anywhere near as much as calcium-related fatigue, and it doesn't last very long. So if you've got metabolite-related fatigue there, you will dissipate it within a few minutes and you can get on with whatever else you want to do, and there's no problem with that. Calcium-related fatigue, once you create it, you're stuck with it until the following day or the day after or whatever. It just doesn't go away. So we'd always want to do the isometrics in the order of contracted down to stretched. And then, of course, bear in mind that if you're combining this into a workout with other things, just bear in mind that your isometric stretch position contraction might then cause you issues for something that you want to do afterwards if it's a dynamic, if you're doing isometrics first. Interestingly, Grimek has talked about doing this at the end of a workout as an addition. When I program isometrics in athletic contexts, if you're using a relatively contracted position or even a mid-range contraction, you can throw them in warm-ups. They're really cool to throw in warm-ups because they really don't create very much fatigue at all if you do them in this way that we're talking about here.
So obviously, if you weren't doing any other exercises for that muscle, it wouldn't particularly matter if you were doing it.
No, not at all. No, if you're doing this as a replacement, then it doesn't matter. But you just do them in the order of contracted down to stretched, and that's absolutely fine. Now, with 5-second contractions and leaving a minute or so between contractions and only doing a handful of them, I don't think it's important to worry about the stretch position causing calcium-related fatigue, because it's not. I'm just pointing out that optimizing the workout in, for the best possible result, we would always do them in that order.
How stretched must that position be to exponentially increase the calcium ion fatigue mechanism?
So I think really contracted down to mid-range, so the top half is probably okay. Anything in that bottom half is probably where you're going to have to start thinking about it. So I would just look at your joint angle range of motion and go, top half, I'm kind of free range, do what you like. Bottom half, you're going to have to start just being aware that there might be an issue. And again, this comes back to if people want to volumize a little bit, then volumize with the top half of the range of motion.
I'm sure we're going to get into this at some point, but I just want to put it out there in case it's not something you're planning on covering. So obviously we've dispelled the myth around the velocity. The next biggest objection I see to isometrics is once someone understands that, they say, well, hang on, no, you need to work through the entire range of motion. You need to provide tension or stimulus, or I don't know what they would argue, throughout that entire range. Obviously, we've just seen with Grimek that he did do these different positions. I don't know if that's something you're going to cover with another point, but I just wanted to put that out there.
Yeah, so basically, isometrics are going to follow the principle of neuromechanical matching in the same way that dynamics do. So when we analyze a dynamic strength training exercise, the way we approach looking at it is we go, what's the most difficult part of the movement? Where do I experience peak effort? Another way of talking about it is to say that where is the sticking point? But basically, wherever you feel the peak effort point in the range of motion, that's the point when motor unit recruitment is going to be highest, and that's going to correspond then to, you're going to look at that point to the range of motion and go, which muscles or muscle regions are doing all of the work at that particular point. Now, the isometric is doing the same thing, but you're freezing the joint angle and you're saying, I'm only going to work at that joint angle. So if you've got a dynamic movement with a very clear point in the range of motion which has peak effort, and you've got an isometric with peak effort at the same point, you're going to see a very similar pattern of hypertrophy. Now, the dynamic will be a little bit messier. It'll be spread a little bit more kind of around the edges across other areas that are related as you approach and leave that point in the joint angle range of motion. But the isometric won't. It will be much more kind of literally whatever fibers have best leverage at that exact point are going to be the ones that get the most stimulus. So the isometric is kind of really fine-tuning and isolating a much, much smaller region of muscle area than the dynamics are doing, because they're kind of muddying the water a little bit. If you muddy the water even more, where you get a very, very flat resistance profile, you're going to basically just spread the stimulus across a bunch of different places. So ultimately, the magnitude of the hypertrophy is probably going to be quite similar, although differences depending on, one thought that I often have is, well, if you have a pure isokinetic, then you're going to spread the hypertrophy across all the possible areas that you could, because you're using max efforts and everywhere is going to get an equal kind of stimulus. In that scenario, if you've got an even distribution of motor units at different thresholds across the whole muscle group, then what you should see is that you actually get slightly better hypertrophy. Now, this has never been seen in research, so I'm a little bit kind of twitchy about this, but you should actually see a little bit more hypertrophy across the in terms of total muscle tissue, because you're targeting all of your highest threshold motor unit muscle fibers, all of the fast twitch fibers. If you just hit one little area, there's quite a decent probability that a bunch of those muscle fibers that you're training there are actually capped out. They're plateaued. So even though potentially you could get the same hypertrophy if you were a beginner, you would. But if you're an advanced, then your hypertrophy capacity here is here, but you've got that same chunk across the entire muscle if you do a accommodating resistance, very isokinetic style contraction. Is this making sense?
Yeah, let's work through the overhead press as an example here. That he performed, because I think that will maybe illustrate this a little bit more clearly to people. So throughout that, let's say someone is doing that dynamically and they're not doing any isometrics, and you've mentioned this litmus test of where's the sticking point. So let's say someone's doing an overhead press and they have a sticking point in that more bottom position. So for them, they're going to be getting more middle delt stimulus than they would be, say, anterior delta triceps, yeah? And so one would potentially make the argument, or what I hear online is, well, no, we need full ROM for this maximal hypertrophy stimulus. But in fact, let's say you were using this exercise and you were wanting some anterior delt development, then arguably doing the isometric in that singular position where the anterior delt has better leverage, so closer to that top position, that's actually going to be better for hypertrophy for that part of the muscle than doing this dynamic repetition. Now, you've then given an example of a flat resistance profile where there's no sticking point, where basically the entire repetition ends up being a sticking point. And you're saying that if one were able to do that, then what? Then wherever we see this transition to another muscle or region having better leverage, well, each of those regions are going to get this maximal stimulus.
Yeah, but it's obviously in a dynamic contraction, you pass through that point relatively quickly. So you're getting this tiny stimulus applied to a very large range of different areas of the muscle, in contrast to the isometric, which is giving you more depth rather than width. Now, the point I'm making is that if you're a beginner, then it's not going to matter, because you've got capacity to grow everything and you're just going to get, depth and width doesn't really matter. You get the same kind of stimulus usable stimulus across everything that you're doing. But if you're an advanced lifter and you've only got a tiny bit of a capacity to grow, then what you're going to see potentially is that the isokinetic might give you a little bit of stimulus across everything, whereas the isometric, the dynamic with a very strong sticking point, might literally just be giving you this tiny little bit of capacity to grow, because everything below that is just not really capable of growing. Now, the other side of this issue, giving aside the fact that we don't generally have access to accommodating resistance of that nature, the isometric is really still very interesting for the advanced person, because you can literally target things that you may not have been targeting before. Now, the example you gave obviously is the overhead press. If you've got, it's typically the sticking point below the horizontal, you're going to find that you're always just training the middle delt with that exercise. You might find that doing some isometrics above the horizontal, it produces some really interesting results. In terms of anterior delt development, which you maybe not able to have, or maybe you don't have the equipment to be able to do otherwise.
So it's a very interesting method that one could think about for some of these exercises where there are different muscle regions that actually contribute differently at different points in that repetition.
Yeah, absolutely. I mean, I think the isometrics is a really, really cool way of doing things that you might not otherwise be able to do. So I've got to remember we're always comparing stuff to our standard strength training exercises because that's what 99% of people are doing. 99% of people are going to go to the gym and they're going to use whatever resistance profile is available to them. Yes, there are like a tiny number of people who have access to isokinetics and they do play around with those things and they, kind of are able to do that, but most people aren't. So we've got a situation where we're talking to a group of people who are using standard strength training equipment. They aren't going to be able to have that perfect resistance profile. So isometrics are really interesting for them because they can look at their existing resistance profile and they can go, okay, so my sticking point is down here. If I do some isometrics up here, then I'm going to be targeting stuff that I'm just not targeting with this dynamic exercise. So you've got your overhead press, whatever, and you notice that it's really difficult to the bottom. Great, keep doing that. And we'll put some isometrics in that are higher up, and that then kind of gives us some growth that we're not getting elsewhere. And I think that's in one respect, you could say, well, is the Grimek approach overkill in the sense that, he's kind of scattering across the whole muscle? What he could do is look at what he's already got in terms of dynamics and go, well, I'm kind of already covering those parts of the range of motion with my sticking points in these dynamics. I could just do my isometrics in parts of the range of motion that I'm not already covering. So you could take it a step further and try and maybe do a little bit more in the areas that you're not covering, a little bit less in the areas that you're already covering.
It's the same thought pattern one would use if they were to look at partial movements. If you were to look at a full ROM, again, using the overhead press as an example, and like you said, okay, maybe your sticking points in the lower part of that movement, and then you decide, okay, I'm going to use a partial movement as well, and just do the top half. Like it's the same thought pattern that will lead you there.
I'm laughing because last time I think we did the podcast, I talked about everything in exercise science as a spectrum. So you kind of have super stable exercises at one end and you've got like really unstable stuff at the other end and everything else is in the middle. If you look at contractions, you can go from full range of motion at one end of the spectrum to isometrics at the other. And your partials can get smaller and smaller and smaller and smaller and smaller until it becomes an isometric. It's a really, really cool illustration of exactly the same point. Dynamics and partials is the same thing as dynamics to isometrics. It's just that you've squeezed the duration or the amplitude of your repetition down to zero.
Mm-hmm. Yeah, it's very, very pinpointed, like you said. Now, people who are aware of isometrics will know that there's different definitions or different types of isometrics that one might use. And most commonly, the two that are discussed most would be overcoming and yielding isometrics. And there's a lot of confusion I see from people who are aware of isometrics as to which one would you use? Which one's best for hypertrophy? So let's talk about what are those, what's overcoming and yielding, and is there a difference from a hypertrophy perspective?
Yeah. So essentially, an overcoming isometric is one that you're trying to turn into a concentric, essentially. So a yielding isometric is one that you're going to end up turning into an eccentric if you're not careful. So that's basically the difference. So you can kind of imagine it if you've got a Smith machine set up and it's locked in place and you can't move the bar and you're set up and you just push on it, that's an overcoming by definition, because if you take your hands off the bar, it doesn't move. So a yielding would imply that it's trying to squash you as you're in the process of, holding it in place, whereas the overcoming is that you're actually trying to move it away from you and it's not got any chance of, kind of squashing you because it is actually fixed. So the overcoming is going to have a very slight element of concentric to it, and which actually isn't that different from isometric, so it kind of is a fairly neutral isometric. The yielding is going to have a little bit of an element of eccentric about it, and that's where things get a little bit interesting, because you're going to get a little bit of passive tension. you're going to, if it turns into a true yielding process where you're actually then turning it into an eccentric contraction, you're going to get a lot more of that as the contraction progresses. So essentially, you're getting like a tiny little flavor of the concentric and the eccentric in your isometrics as you're doing them. In practice, I'm not a fan of yielding isometrics, especially when they turn into genuine eccentrics, because I think because what tends to happen is that you accumulate some fatigue and you turn your isometric into an eccentric. So imagine you're just holding a weight, and as you get to the point where you can't hold it anymore, the weight starts to move towards you and then finishes at a certain point. That is a kind of a quasi-isometric or sort of yielding isometric into an eccentric. And the problem with that is that a lot of the good stuff that we get from eccentric contractions with maximal efforts comes from an absence of fatigue. And a lot of the problems that we get in post-workout fatigue situations when we're doing eccentric contractions comes from allowing fatigue to develop in those eccentric contractions. So that's a hugely summarized view of the physiology, but broadly speaking, what that means is that you're not getting a lot of good stuff from allowing isometrics to turn into eccentrics, and you're not getting you are getting a lot more bad stuff from allowing that to happen in terms of post-workout fatigue. So honestly, if you're thinking about doing either of these two and you've got the choice, I would always go for an overcoming isometric, or that sort of side of the equation. I don't see an enormous amount of value in the yielding side of things unless you really, really know what you're doing and you've got a specific sporting situation that you're trying to mimic. I wouldn't want to go there. And even then I would be asking myself the question, would it not be better just to do a maximal effort eccentric and be done with it? Is that not going to get me the same place? Now, a tiny number of places that might not be true, but I think most of the time it would be true.
Yeah, that's interesting, isn't it? Like, for me, when I look at yielding isometrics, I'm like, what are you doing? You're kind of doing an isometric into an eccentric, like you said. And if you wanted to do that, why would you not do both? Why would you not do an overcoming isometric and then do an eccentric? Like, I don't really understand the idea of blurring the two together. And like you said, you're kind of losing out, and really you kind of lose out in both in a sense when you're combining them.
Yeah, I mean, it's a similar situation. It's like a lukewarm, it's neither hot nor cold. It doesn't really do anything well. And I levied the same criticism against upper-lower splits a while back. And I said upper-lower done with 2 of each type of workout, so 4 workouts per week, is not solving any problems. It doesn't solve a problem that we have in any other training program, and so it's lukewarm. It doesn't really do anything well. And as a result, people started running around the internet saying, Chris says that upper lower, 4 times a week, as in 2 of each type of workout, is the worst possible thing you can do. And I was like, no, I didn't say that. I just said it's not a program that solves any particular problems. I actually think it's better than bro split, but that's not the point. And the same thing happens here. It's like, Chris says that, yielding isometrics are useless and you shouldn't do them. No, I didn't say that. It doesn't do anything well. It clearly will produce a whole bunch of adaptions and, it'll work. It's just not doing an eccentric contraction well. And as a result, I think it's not giving you anything extra that an overcoming isometric can't give you in the context of what we're trying to do. I would always pick maximal effort eccentrics instead of overcoming isometrics. I would always pick supramaximal eccentrics over a yielding isometric if I was trying to get eccentric related adaptions, and I'd always pick an overcoming isometric over a yielding isometric if I was trying to get hypertrophy or sort of joint angle specific strength gains. So I don't see, and hopefully that helps clarify what I'm doing here. I'm trying to point out that if you've got a toolbox of specific tools for specific purposes, I don't see where yielding isometrics fit.
Yep.
They don't do anything well. Now, as I say, there might be the 1% of a 1% scenario in a sporting situation where you can say, oh, actually, I do this and that works great. But I don't think that applies for most people most of the time.
Yeah. Now, just to make this incredibly clear for people, why are we saying that a yielding isometric is likely going to lead to less hypertrophy benefit than an overcoming? So you've mentioned overcoming, you're trying to push it. You're trying to lift, not push, you're trying to lift that load. Yeah. And yielding, you're trying to resist that load. So what is changing from trying to resist the load and then potentially turning that into an eccentric as opposed to trying to lift that load that's making it less suitable for hypertrophy?
Sure. So essentially, as soon as you start stretching an activated muscle fiber, you start getting calcium ion related fatigue. and it's really pronounced. So that then inhibits your ability to produce mechanical tension on a single fiber level. One of the most sort of informative, if you like, illustrations of this point is that if you look at the dose response of hypertrophy to training volume in normal strength training situations, there's a non-linear dose response, but it does show increasing amounts of growth with increasing volumes. If you look at eccentrics, it pretty much kind of caps out after 3 sets. You kind of go 1 to 3 and then it's a flat line. And that's really, really useful, because what that's telling you is that the physiological understanding that we have is correct, which is that as soon as you start accumulating a ton of calcium amyloid fatigue, mechanical tension starts dropping and you start to find that you can't stimulate the hypertrophy that you're trying to stimulate. So if you're doing multiple of these yielding isometrics and they are actually turning into a bit of an eccentric, you are going to start stacking calcium amyloid fatigue in the same way that you would do as if you were doing a lot of stretch position, in fact more so than if you're doing a ton of stretch position isometrics. So ultimately, again, if you want to volumize this stuff, you wouldn't touch yielding isometrics. You would be absolutely on the overcoming side, because you want overcoming in contracted position, and then you're going to be able to volumize as much as you like within reason. Whereas a yielding or a stretched position, you're going to have those calcium amyloid fatigue problems.
And if someone's listening to this thinking, well, hang on, why don't I just say I'm doing 15 seconds worth of overcoming? So I do my 3 mini sets, I do my 15 seconds worth of overcoming isometrics. Why can I not finish with a single yielding isometric and get a stack of this passive tension? Is that not a viable way of doing it?
So with the durations that we're talking about, it is. If you start going to longer durations, it ceases to become quite so interesting. So if you're doing 5 seconds and you're getting a yielding point at the end of that 5 seconds, then yeah, absolutely, that will work. And you'll get some decent passive tension at the high threshold motor unit and high end of the high threshold motor unit pool. If you start, kind of disregarding the suggestions that I've made and start trying to do 15, 20, 30-second isometrics, and you're getting, kind of yielding at the end of that 20, 30 seconds, no, it's not going to work. It will, but it just won't work very well, because what's going to happen is you're going to get a lot of spinal CNS fatigue. It's going to reduce the access to high threshold motor unit that you're trying to train, and you're going to find that you don't get that same sort of top end stimulus of the muscle fibers that are corresponding to the high threshold motor units. So obviously then also you've got that very large duration of contraction into the yielding. You're going to find that you've already got calcium ion accumulation when you hit that point. You're then doing an eccentric in a calcium ion accumulated state, which is really silly. Pre-fatiguing going into an eccentric is just not clever, because ultimately you're already going into a scenario where you're about to experience calcium amyloid fatigue, and you're going in there carrying bags full of calcium ions with you. I mean, that is just asking for a post-workout fatigue problem, really. So again, that scenario, you're getting the worst of both possible situations, because you're diminishing your stimulus dramatically with the spinal CNS fatigue, and simultaneously you're racking up a ton of post-workout fatigue with your calcium ion accumulation.
So recruitment is significantly lower in an eccentric than it is in a concentric. Now, how much does that CNS fatigue that one would accrue in, say, a 5-second more contracted position isometric, how much is that going to have an effect on recruitment if that then turned into a yielding or an eccentric?
So yeah, exactly. I mean, this is the kind of thing that we don't have very good data on. So, you could argue that maybe obviously you're getting to a point where you're very fatigued and you can't hold the isometric anymore. You're definitively in the territory where you're going to be, maximally resisting that eccentric. How much of that maximal resistance is going to be, doable with a lower level of recruitment really depends on what the ratio is of the muscle fiber force in eccentrics to your isometrics. Now, yeah, you're going to lose a little bit of recruitment off the top end anyway, so arguably it's even worse than I was describing.
So you've pretty definitively said that you can't see a utility for a yielding isometric beyond what you could get essentially by splitting up the eccentric and the isometric as an overcoming. I think that's fairly clear there. So then if we're talking about programming overcoming isometrics, is there anything else people need to know about them before they start implementing them?
I think that we've kind of captured the important points here. The important points are exactly what we saw with the Grimek program. We're talking about a low volume of 5-second contractions with probably a minute between contractions, ideally done at a number of joint angles. Now, just to be clear, if you want to work in the short muscle length end of the spectrum, the contractor position, you can still change the joint angles a little bit. You just don't have to change them as much, So you can work with joint angles that are relatively close together, and you will get more coverage by doing that. So doing a relatively small number of maximal effort 5-second contractions with 1 minute rest between contractions, and we're spreading them out across a bunch of joint angles. And I think that's a really, really good recipe. I mean, it never fails to amaze me just how dialed in these guys were. Like you threw that together like in 5 minutes after I message you and say, I'm getting all these questions about isometric contractions. Let's do a podcast on isometric contractions. And 5 minutes later, you've got, hey, I've got this amazing isometric routine that Grimek did. And I'm like, that's just ridiculous, that we've got that you've got that information. And it turns out to be literally perfect for the conversation that we're going to have. So honestly, I think that I've got very, very little, if anything, to disagree about with that routine. I personally would do less at the stretched end of the spectrum, more at the contracted. I would probably even do them at the beginning of the workout rather than the end. But other than that, I've got very little to say that is different, to be honest.
I know this, you might not want to get into it. It's a bit of a, not a can of worms, but it's adjacent topic. But for people who did want to use isometrics from a strength perspective, is there anything to comment on there?
So I often get asked this question in my consulting side of things, and I do like this approach of doing a couple of max effort isometrics and relatively contracted positions in the warm-ups or towards the end of a warm-up. I think it works really well for athletes in a number of different areas. And the main reason that I like to do them is to produce an increase in motor unit recruitment. So imagine you've got like a powerlifter or another strength athlete. They don't tend to do anything at high velocities. Even when they do what they call speed work, it's not actually that fast. So, they're not used to moving quickly. Now, with a speed athlete or a team sports athlete, I would be saying we're going to try and increase motor unit recruitment by doing our speed work, actual speed work, not what people think of as speed work, but actual speed work, maximal efforts in unloaded situations. We do those at the end of our warm-ups because that not only gives us speed-related adaptations, it also gives us an increase in motor unit recruitment that we can then benefit from in our strength-related adaptations. So with team sports and other speed athletes, I would always do my speed work as part of the end of the warm-up and then segue into strength stuff. With powerlifters and other strength athletes who are not accustomed to that kind of rapid movement, you don't necessarily want to start throwing speed work at them. You'd be like, well, let's do isometrics instead. And you get a really nice effect. And the added benefit of isometrics is that you can do them with relatively low amounts of muscle mass. You can do them single joint, you can do them single limb. You can really push the parameters that have the ability to increase motor unit recruitment as an adaptation. Plus, you can get joint angle specific about it because there's a joint angle specificity effect to these neural adaptations. So you can really kind of start analyzing your powerlifter and go, where am I seeing weakness and sort of difficulty? And you can be like, right, well, let's do some isometrics of specific muscles in those specific positions. Now, the difficulty you're then going to have in practice is that a lot of those positions will be stretch positions unless you're working with geared powerlifters, in which case it might be different. But generally speaking, with powerlifters who are not using equipment, you'll find that most of the difficulty is in the stretch positions. So even so, if you're using just a couple of those contractions, you can get some pretty interesting results. So I think that there's some really cool stuff there for powerlifters to look at and other strength athletes to look at, because the overcoming isometric is so easy to do in a way that doesn't create large amounts of fatigue, such that you can incorporate it relatively early on in the workout before you start getting too tired from everything else you do.
Yeah, and you've mentioned doing it early on in the workout, and obviously, as you've just said there, part of the benefit of doing it is you're not causing this fatigue that's going to affect the rest of the workout. But if you're using it for the purpose of motor unit recruitment enhancement, then obviously that's going to be more effective in an unfatigued state than doing it at the end. Grimek, doing it at the end, really we're looking at this more from a hypertrophy perspective. Not that doing it at the start, it's going to be negative for hypertrophy, but you're not getting these more strength-specific benefits that you might be getting if you did at the start. You
exactly.
did mention the joint angle.
There's a really good argument. There's a really good argument to moving it to the beginning. I don't see I think on balance, I would always err on the side of putting it.
Yeah, I always program it at the beginning as well. I'm trying to think if I could see a benefit to doing it at the end, and I am struggling to see one. And even just from almost like a psychological standpoint, I actually like almost using it as a warm up. Like there's something, doing these sort of max effort sets. It's a nice way to kind of begin the session. I don't know. It does seem a little bit, I don't know. I don't even recall even trying it at the end of a workout. So perhaps I will try that and see what it psychologically even feels like. But yeah, it does make sense certainly at the start of a workout. You did mention this joint angle specificity. So if someone were using the isometrics partly for that purpose of increasing strength in a particular lift, how close to that sticking point, maybe that's a question, how close to that sticking point, or where you're performing that isometric, where is there going to be this sort of overlapping increase in that joint specific angle? Does that make sense what I'm trying to communicate there?
Well, I mean, obviously it's best to try and identify the joint angle as well as you can, because the closer you get to it, the better the effect is going to be. But you do get a spillover effect, at least 10 degrees either side. So, different studies show slightly different results. But, you're going to get a spillover either side of that joint angle. Honestly, I think it's worth putting the time into trying to identify precisely what the joint angle is that you want to train. Now, sticking point analysis is a science in itself, and people can get really into it, and I think it's worth reading up on the ins and the outs of it. The important thing to remember is that you're not looking for the point in the range of motion where you get stuck, even though it sounds like that's what you're looking for. That's not. You're not looking for the point where you stop. You're looking for the point where you stop accelerating.
Mm-hmm.
So you've got to go backwards a little bit from the point where you think the sticking point is, because a lot of people will look at a squat and go, oh, my sticking point is here. And I'm like, no, it's not. It's actually like 10 degrees before that, because that's when you started decelerating.
Yep. So if you're driving a car and you hit mud and then you start getting bogged in the mud, the point where you stop, that's not the bit that mattered.
That's not the bit that mattered. It's the point where you hit the mud in the first place. Yeah. So you're looking at the way you start decelerating. So you kind of got to work backwards from where you thought the problem was, and go and start doing the work there, because that's where the real problem is. But as I say, the essence of sticking point analysis is complicated. But ultimately, that's the most important thing, is to work backwards from where you think it is and try and identify the joint angle further back when the problem actually started.
You mentioned this spillover effect 10 to 15 degrees, and partly why I asked that question is when I program these from a strength perspective, and let's say it's with clients who maybe I don't know where the sticking point is, maybe it's more a general program template or whatever, what I would do is program those isometrics usually about a quarter of the way up, and then halfway, and then 3/4 up. And programming, say, in that fully stretched position, not only you're getting this calcium ion issue you talked about, but if you're getting this spillover effect 10, 15 degrees either side, well, you've just lost half of that if you're doing it at the end. And same if you're doing a fully contracted position, you've lost half of that as well. So if I were to program it more generally, I would try to maximize that sort of spillover effect, as you mentioned.
Yeah, I mean, and that's really what Grimek is doing. I think he's trying to get the coverage across multiple different locations. Not in his case, obviously, from a hypertrophy point of view, with neuromechanical matching, but same thing applies to neural adaptations as well.
So practically, someone wants to use some of these. We've given a few points there. You talked about maybe using them at the start of the workout, makes a little bit more sense. You've talked about how you can decide where you would perform them in that joint specific or in the particular repetition based on which muscle you want to target, or based on strength adaptations or whatever. What else would be helpful for people to know in terms of using these? So if someone, I guess one question there would be, and I'll let you speak to this, because I know we've talked about this for years now. Isometrics is something years ago we were talking about, like me implementing them in my own programming. And you always had one very specific concern or something that a limitation you saw to them. So do you want to tell us about that?
Yeah, so basically the problem that everybody is going to run into eventually with isometrics is that you don't know whether you're getting better or not unless you've got some objective way of measuring that. Now, some people do have load cells that they've got access to. I know a bunch of climbers that use load cells to see what their isometric strength are like. if you've got access to that technology, then fantastic. You can now use isometrics to your heart's content, and you're always going to know whether you're getting better or not because you can literally read the number off the screen. If you don't have that, you are going to be really struggling to know whether or not your strength is improving or not, and therefore whether what you're doing is working. Now, in the context of the athletic situations that I described, I don't actually care that much because I'm not doing it to produce a strength gain in the specific context that I'm doing it in. I'm doing it to trigger an increase in motor unit recruitment. I'm setting the parameters up in a way that I'm confident will generate that output, and we just kind of roll with it and hope for the best. In the context where you're using it for hypertrophy, you want to be confident that it is working to produce hypertrophy, therefore you want to see some progressive overload, and you're not going to see that. Now, as you pointed out, we've been backwards and forwards on this many, many times trying to find an elegant way of solving the problem. I still don't have one, so maybe you've got one by now, I don't know. But honestly, I've got to the point where I'm like, in the situations where somebody's going to find themselves in where they have to do isometrics because they've got no other choice, that's going to be such a limited number of situations. I actually find myself in one right now, but only for the next few weeks. But ultimately, again, you come out of that and you go into something else, and then you're back on the kind of normal strength training program where you can see progressive overload happening because you can measure reps changing. So yeah, that's been my biggest problem with using isometrics in a hypertrophy context, because I like to know whether a program is working. I don't like to be unsure about it. I like to see it happening, and isometrics don't let you do that unless you've got a load cell.
And so obviously if you were doing, like in this example Grimek gave, if you were still doing curls, say on another day, or you were doing a set of curls in that workout anyway or whatever, then you can obviously be tracking progressive overload on other exercises for that muscle, but you don't know what's causing that adaptation.
Yeah. You don't know whether it's not the dynamic training that you're doing anyway.
Exactly. I've thought long and hard about ways to overcome this. One idea I had was selecting a 5 repetition max as an example, like a 5 rep max load for a specific. So let's say you were performing the isometric in the mid position of an overhead press, then selecting a load that is a 5 rep max for that position. I'm not saying your 5 rep max overhead pressing load, but say a park from that position, and then essentially doing almost what would be a yielding isometric where you just lift it the slightest bit, like a centimeter up, so you know when you lift it and you know when you're no longer lifting it, right? So it's not technically an overcoming isometric in that you're moving an immovable, or you're trying to move an immovable object, but by doing that and then increasing that 5 rep max load over time, or increasing that load over time, and then testing it, say, every few weeks and seeing, is this still a 5 rep max load, or is it now a 6 rep max load? That would be a way that one could have some assessment at some point in time, even if it's every few weeks, to see if one were progressing or not.
Yeah, absolutely. And I think really that's kind of one of the only ways I can see it being feasible to track progressive overload in that situation. Of course, one of the situations in which people find themselves in where they want to use isometrics is when they don't have access to a gym. So I would say the biggest use case of isometrics is when you're stuck in a hotel or in a middle of nowhere, and you've literally got yourself and a room, and you're trying to find things to pull on and push on to create isometric contractions. And that's kind of all you've got. Obviously, you've got no way of doing those gym-related testing checks to see where you're at. And I think really that's kind of my only problem with them. It's a practical one. But again, given that most people most of the time will only find themselves in those limited scenarios for short periods of time, weeks or months. Obviously there are scenarios where you might have to go and work somewhere that has a very limited gym access for a year or two, but less likely, I think. I think it's one of those things where you just say, well, I'm not going to worry about the progressive overload thing. I'm just going to do what I think looks right on paper. And when I get back to the gym where I've got access to equipment, then I'll see where I'm at. And I think that's probably what the answer is in practice.
Yeah. We're not going to go into this in detail, but I do just want to mention again for people who are looking at implementing these, we are talking about max effort isometrics. We are not talking about pauses, because I see people use the language of isometrics for pauses a lot.
Well, it's the same as people using the language of eccentric contractions for the eccentric phase of a normal strength training rep. It's just the fundamental lack of understanding that there is a difference in effort between these two things, and that totally changes the effect of the exercise. Absolutely. Pauses can be isometric if you have the ability, if you're, say, for example, you're pausing at the end of a chest press and you can push into the machine so that you're actually now doing an overcoming isometric. But that's rare. Most of the time, as you say, we're talking about pauses, they're actually sub-maximal situations and they're not going to do anything remotely similar to what we're talking about. But as you say, we'll cover that on another day, so we don't need to dig into it too much now.
Yeah. Exactly. Practically speaking, is there anything else you think would be helpful for people to know if they were wanting to implement these?
No, I think I've said the same thing about 10 times already. So,
and there's not it's not like you're limited to only doing it for multi-joint exercises or for single joint exercises, or you don't have to do barbell exercises like what Grimek was doing. You could do it in a machine. Like there's plenty of ways for one to get creative and implement these on different apparatus with different exercises, different muscles. And arguably, depending on what your goal is, it maybe makes more sense to get more specific and granular with it rather than using it in a multi-joint exercise. It depends on your goal, doesn't it? Obviously there's benefits of doing it in those particular exercises. If we look at isolating a region which isn't normally getting trained well in that exercise for you, or if it's a goal to increase the strength in that particular lift. So what I guess what I do like about isometrics is they're quite a versatile tool. Like in some ways more versatile than just a dynamic repetition would be, or contraction, because you can kind of isolate out what you're particularly wanting to work on. So it's just a tool, I think,
absolutely.
to refine that.
Some of the one thing I was just thinking while you were explaining that, the same rules apply as for dynamics when it comes to things like stability and muscle mass and all of that stuff. So, the same rules. So if we're constructing an isometric exercise that we want to use, we don't want to be massively unstable while we're doing it. You want to be very, very stable. You don't want it to be moving you around. Same thing with muscle mass. You don't really want a ton of muscle mass if you're trying to produce the maximum level of motor unit accruement and stimulate the growth. So, that's just like we've talked about that before, but it still applies, the same kind of rules. I think you can construct some really interesting possibilities. Some are easier than others. Some stuff is just really difficult to make work, and other stuff is really easy. But I think they're really good to play around with.
To give people one example of how I'm using them in my own training, just to get your creative juices flowing. So I often will have a particular lift that I might be focusing on in a particular phase. And then, so for example, at the moment, I'm doing a lot of behind the neck pressing. And then what I will do on either at the start of, usually I do it at the start of, if I'm doing like an A-B split. My A-B, I do full body A-B, but my A-Bs look very similar. Like each program looks very similar. There's only a few exercises that differ. So technically it's an A-B, but it's almost like an A1, A2 in a sense. But on one of those, I will normally add in at the start some isometrics, and I will do it for that 1/3 or 1/4 position from the top, halfway from the top, and then a third or quarter from the bottom. And I'll do that on that sort of goal or that target lift of that phase for myself. And then I may or may not follow that up with just one set of normal dynamic contractions for that exercise. And then I've got the other day where I'm just doing it as a standard set where I can, I'm seeing or tracking my progressive overload in that. And then each phase I might pick one, I might change it and pick a different exercise to do it with. And I'm tending to use it more on those exercises like the overhead press, where I know that there's regional differences in that particular exercise. So for me, whatever muscle is not getting trained well in that normal set, I can actually isolate out.
Yeah, no, that makes sense. I mean, that's very similar to how I would approach it for powerlifting training, to be honest.
Well, thank you, Chris, for hopefully clearing up what is a topic online, which I think is covered in so much confusion. So hopefully that's demystified or taken away some of the fog and given some people some ideas or some framework or foundation to actually implement it in their own training. And like we've said, it's a very versatile tool. Where we'd love to hear you guys using this. And we don't think everyone needs to be doing it for every single program. It's not like it's a holy grail of hypertrophy, but it is versatile and it is something that has benefits and specific utility in whatever, specific cases. So we'd love to hear how you guys use it. Thank you, as always, for joining us, and we hope you'll join us for another episode.